Okay, it's 12 o'clock, so I'm going to get things started because I know we're all on a tight schedule. Um, so my name's Ed Giesrecht. I'm going to introduce our speaker today for the Illuminate Speaker Series. So it is certainly my pleasure to introduce Dr. Cowley. I have known Kristine for 25 or 30 years and worked in a number of different contexts, and it's been a pleasure and a privilege to do that. I've been provided with a short and highly inadequate background, which I will share with you now, and then we'll get started. So Kristine Cowley is an associate professor and director of the Spinal Cord Injury Research Centre at the University of Manitoba. She received a PhD in physiology in 1998, investigating the neuromechanisms and pathways generating and coordinating walking within the spinal cord. Dr. Cowley holds a prestigious Canada Research Council chair in spinal cord function and the health after spinal cord injury. Some of her most recent research focuses on characterizing the inequities and disparities in health policy in Canada as it relates to public support for medical services and supplies and mobility equipment that is required by people living with spinal cord injury to survive. So with that, I will turn it over to Dr. Cowley, and I'll let you introduce both the title and your presentation.
Sounds good. I'm just going to get this into presentation mode. Okay, does that look okay? Okay, good. Yeah, so thank you very much for the invitation. I'm going to be talking about life after spinal cord injury and research to improve health and function. And I will start with the traditional territories acknowledgement that the University of Manitoba campuses are located on original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. And just as an overview, I want to talk a little bit about spinal cord injury and lost functions, and then give a little bit of an overview about the day in the life of autonomic dysregulation for a person with cervical level injury. I want to talk a little bit about exercise and Paralympic performance and the neurophysiology of selected lost functions that are related to performance limitations after injury, and these relate mainly to homeostatic regulation, or how your body responds to temperature changes or to changes in your position, and the responses that are required in order for you to maintain normal blood pressure or to increase blood pressure in order to exercise. And then I want to talk a little bit about some exercise physiology and rehabilitation research that we've been doing, which the focus of which is to increase the health benefits of exercise, and specifically looking at ergonomic strategies, and then trying to understand how those ergonomic strategies might relate to underlying physiological mechanisms to explain why these ergonomic strategies might actually help in terms of exercise performance. And then finally, I'm going to talk about health policy research, a little bit of health policy research that we've been doing. And the goal of that research is to improve access to needed medical services, supplies, and equipment that is essential for life after spinal cord injury. And I'm going to use three perspectives to do this. The first is as a person living with cervical spinal cord injury, and then just demonstrate some of the dysfunctions that go with it. And I want to talk a little bit about Paralympic track and long distance exercise, and the goal of people trying to increase their performance, both for competition and just generally. And then also, what can we learn from people with spinal cord injury to either inform research or to identify research needs? And then I'm going to focus, also the other third perspective is as a research, and the focus again is on exercise physiology or ergonomics to improve exercise function, and then policy research for health and life quality. And then what all of these have in common is that the focus is on spinal cord and its functions. So in terms of the first perspective, people with spinal cord injury have an extremely limited ability to regulate key spinal sympathetic functions, particularly if you have tetraplegia. Now, everyone's familiar with the paralysis and the complete or partial loss of sensation that comes with spinal cord injury, but they're less familiar with the autonomic dysregulations that occur. And if they do, they often think about bladder and bowel control and less so about blood pressure regulation or temperature regulation, but all of these are key factors because the spinal cord basically is the motor control center for all of the tissues and organs of the body. So we think about movement and we think about sensation, but we think less about is that basically the spinal cord is the final common pathway before the output to all of the targets and body tissues of all humans and mammals. So in terms of voluntary muscle activation, they're actually quite similar between C8 and T8 spinal cord injury. And when I say that, people who haven't thought about that before, they go, no, that's insane. But if you think about C1 to C4 injury, I'm showing the muscle patterns or the muscles that are innervated between C1 and C4, and you can see muscles of the neck and muscles of the back. As you get down to C5, you can see you start to fill in some of your pecs and the muscles of your arms, including you start to get bicep and tricep. And as you go down in terms of the spinal cord injury level, you gain more and more muscle function. And this is well known. And, you get down to C7 or C8, and your relative innervation of the muscles of the head and the neck are relatively complete. Of course, hands, there's still the muscles of the hands are not appropriately or not adequately innervated. So you can have muscle dysfunction, although people with C8 level injury can have a fair amount of finger extension and flexion, but what they're missing is the intrinsic muscles of the hand. But then when you jump down to T8, through all of those levels of the spinal cord, you don't actually increase that much in terms of your muscle innervation, except for the abdominal muscles. And then, of course, you get your full innervation of your hand, which is, of course, very important. But one wonders what's going on between T1 and T8 in terms of the spinal innervation, and what are the functions that are mediated by that region if there really isn't very much gained in terms of muscle function between a C8 level injury and a T8 level injury. And then when you get down to T12, then you have a full innervation of all of the muscles of the upper limb, and you also have a full innervation of a lot of the autonomic sympathetic functions that are related to exercise and body and tissue organ function. So although the voluntary muscle activation capabilities are similar between a C8 and a T8 level of spinal cord injury, the things that are different are related to body function, which are related to our ability to perform movement or to maintain movement. And that includes innervation in the sweat glands, the heart, and adrenal glands. So when you have an injury at T1, you don't have any any automatic ability to regulate sweat glands, and so you don't sweat in response to heat. You will sweat if you have autonomic dysreflexia, but you won't sweat in response to heat. And then similarly with an injury at T1, you won't have appropriate innervation of the heart. So you won't be able to increase heart rate when you have increased metabolic demands and you are interested in moving faster or for performing upper body exercise. So you're limited in terms of your maximum heart rate that you can achieve. And then similarly, there's no innervation of the adrenal glands because they've known from a number of animal studies for over the course of decades that the innervation of the sweat glands, the heart, and the blood vessel smooth muscle, as well as the adrenal glands, and even fat and bone, are innervated at different levels of the spinal cord, just like the somatotopic arrangement for the innervation of muscle. So as you go down in terms of your injury, once you start to have an injury at a level of T2, you actually now can sweat in response to heat, at least up to your dermatome level. And you start to get a partial innervation of your heart. And then this improves as you go down to T3 and T4. And by the time you're at, say, T4, T5, you've almost got normal heart function. And you've also started to get appropriate innervation or the ability to appropriately activate the smooth muscle of the arterial vessels, which allows you to regulate your blood pressure in response to your metabolic demands or whether you're standing or you're sitting. And then as you get down to around T6 and through T9, you start to have innervation of your adrenal glands. And so by the time you're at around T9, all of that capability is present and it can be activated when you move and exercise. And so by the time you're at T11 or T12, you've got fairly normal function of all of these internal organs and body functions. And one of the reasons why you survive after spinal cord injury is because you actually have your parasympathetic innervation, which is the other side of that autonomic system, which the parasympathetic system, as you know, is responsible for rest and digest. And therefore, because the parasympathetic input is quite normal, and it also comes from the brainstem, spinal cord injury doesn't disrupt all of those body organs that are related to digestion and normal function, because that basal level of function is left intact up until the descending colon. And then spinal cord injury will still impair all of your sort of sacral functions that are related to bladder function, bowel function, that are lower than this T12 level. So, so the focus of my research is on exercise-related research and activation of these autonomic systems that help to support exercise. So I just wanted to go with a little example of a day in the life, and this is data related to blood pressure, and it's called an ambulatory blood pressure data, and it's taken over the course of 24 hours. And this was done in myself as a C8 tetraplegic. And of course, I'm not ambulating, but that's what the testing is called. And so you wear a blood pressure monitor, and it's on for 24 hours, and it monitors what your systolic and diastolic blood pressure is over the course of a day. And as you can see here, this is your blood pressure, my blood pressure, actually, when you're sleeping, when I'm sleeping. And then in red is shown after eating. And then the orange is autonomic dysreflexia, or AD, which is occurring not during exercise, or it's not induced during exercise, which I'll get to in a little bit. But the reason why this information was being gathered was because you can have these periods of autonomic dysreflexia, which are sort of unexplained increases in blood pressure. And usually they relate to some nociceptive stimulus that might be bladder fullness or something else that's going on with the body. But for people living with spinal cord injury, they can also have episodes of this that are really unexplained, or they can't figure out what the mechanism that underlies that is. And so one of the reasons why this data was being collected was to try and figure out what was causing these intermittent periods of autonomic dysreflexia that I was experiencing. And just to put that into perspective, during those bouts of autonomic dysreflexia, you can have a blood pressure that's as high as 180 over 90. You can have it go up to around 190 over 90, which is fairly high, and that normally would be the level that you might say you should probably go to the hospital. And if unchecked, or if you don't figure out what the cause of that is, people working in spinal cord rehab and physiotherapy and physiatry know that that can be life-threatening, and that's one of the reasons why they talk about that for medical students who are involved with emergency presentations of people with spinal cord injury. But although spinal cord injury is a relatively rare event, this can be life-threatening if it goes uncontrolled or you don't figure out the source of it. And then the other side that's interesting is that, after eating, for example, you can have extremely low blood pressure. So it can go down as low as 90 over 40. This is also eating. It can go as low as, 90 again over 50, which would be considered really quite low. And so over the course of a single day, your blood pressure regulation can be all over the map. So this instability is related to an inappropriate ability for the brain to control all of that autonomic sympathetic neural architecture that's below the spinal cord injury. And it's because of this lack of appropriate communication between the brain and the spinal cord. And then in addition to that, there's a great amount of dysregulation as it relates to temperature. So this was information that I was gathering because I'm trying to develop some protocols for doing this as a study in people with spinal cord injury, and particularly tetraplegia, to take a look at the relationship between core body temperature under different environmental conditions and to see how widely varying it is. The reason I'm interested in that is because this is sort of an understudied area that largely affects people with spinal cord injury, and particularly tetraplegia, such that they can spend very large portions of their day that when they're they've got their thermal regulation is such that they're either overly warm or overly cold, hypothermic or hyperthermic. So a typical day in July, just to show you the fluctuations in core body temperature, and this is 38.5 to 34.5 down here. Let's say if you're hand cycling outdoors at a temperature of 19 degrees Celsius for, say, about 50 minutes, core temperature can go up from this 37.5 degrees, which would be considered normal. It can go up as high as about 38.3. And then note that even after you stop exercising and you go back into a air-conditioned internal environment, that temperature, that internal core temperature, can stay high for a fairly long, overlong compared to when you stop that exercising. Similarly, when you're indoors, and it might be in a cold temperature, such as what occurs at the University of Manitoba in summer all the time, where it's kept quite cold, body temperature can go down quite low, and it can go down as low as 36.5 or even lower. So it can go down lower than 36 degrees. And then if you start to do some activity indoors, and it might be, in this case, we were working on a research protocol, so this was doing some treadmill activity, temperature can go back up so that it almost gets normalized. So, and you can see this both in the summer as well as in winter. So if you're hand cycling even at -4 degrees Celsius, core temperature can go up from 37 and go as high as 38 degrees again. Although now when you cease exercising, temperature declines fairly rapidly when you were exercising at that very low temperature of -4 degrees outside, which is different than what you're seeing here when you're exercising outdoor in a warmer environment. So the purpose of showing this, and this is also just one last one, is having a bath, a normal bath. You can see internal core temperature can rise from around, in this case, it was a bit hypotensive before starting, a little bit under 36.5, and it can go again as high as 38. So my purpose of showing this was to show how much lability there is in terms of temperature regulation, particularly for people with cervical level injury. And this isn't really very well documented. And the studies that have been done are usually done in environments where people are told to stay under normal temperature conditions so that they can try and take a look at this. But basically what it illustrates is that temperature regulation in people with injury above T1 is really maintained by the cortex. In other words, behavior management. So there's very little ability for the body itself to regulate core temperature. And so these responses are all basically reflex responses to the environment that are then going on unchecked and uncontrolled because of that lack of communication between the brainstem autonomic centers and then the body neural output cells within the sympathetic nervous system that control those things. So I just wanted to illustrate this because it's shows you what the great deal of fluctuations are, and this is just a summary of 7 days of this core temperature monitoring in the winter and then 7 days in the summer. And you can see that there can be in any given day, you can have a low of 35.6 to 38.4. And in the winter or the summer, you can have a mean temperature change in one day of like 1.8 degrees. And so it just shows you the highly variable and widely fluctuating sympathetic reflex responses that are present in people with tetraplegia. So then, in terms of perspective 2, I wanted to talk a little bit about sort of training and exercise and competition and how this dysregulation of the body systems regulate or relates to competitive performance and what people living with spinal cord injury might be interested in improving after injury. So, for example, I've done a lot of wheelchair track. I was a T2 wheelchair athlete, and I would train over 20 hours a week and in all kinds of weather and environmental conditions. And so, for example, in Barcelona in 1992, the average daily temperature was over 28 degrees Celsius. So, which is very hot. And you can see from the earlier example, that would probably cause a very large increase in core temperature if you were exercising under those conditions, given that the sample I showed was only at 19 degrees Celsius. And then after the Paralympics, I began hand cycling, and I've done a fair amount of that, also in all kinds of weather, from -5 to over 30, which also relates to the example of -5 degrees, showing you that you can still get that increase in core temperature when you're outside, but then it can cause a rebound reduction in core temperature that can be quite low. So this is just to identify that these are areas for research that require more work to try and identify means or strategies to try and assist people living with spinal cord injury to lead a more regulated life and allow them to try and perform and exercise under different conditions. And then just, I wanted to also mention that this is the people from Canada who were competing at the time in the Paralympics, and my name was Harder at the time, but you can see that Canada had a fairly good representation, and these are all TW2 athletes. So they're all people who have an injury in the cervical region. They all are unable to regulate their autonomic systems normally. There's also obviously lower levels of classification, which relate to higher levels of function, like the T3s and the T4s, or TW3s and 4s, and they don't have as large a problem in terms of regulating their autonomic systems. So, but what people who want to compete and who want to win talk about is how can we maximize performance? So can you do something to regulate blood pressure or regulate heart rate or improve your blood or your ability to regulate temperature under different environmental conditions? And so this goes back to relating to the spinal levels for key sympathetic exercise functions that are related to this homeostatic and metabolic body functions. And so when you're talking about movement and exercise, you require an increased sympathetic activation of your cardiovascular tissue. You need to increase heart rate, and you need to increase your blood vessel, smooth muscle contractibility. And then you also have to have an appropriate activation of sweat glands and then also your metabolic tissues so that you can have increased fatty acid release and release of catecholamines, which then all goes back to the heart to improve performance. And so, as I mentioned earlier, once the higher you have a level of injury at around T2, you start to get the ability to sweat and to regulate at least the vasculature of the upper arms and the head. And you start to get a little bit of innervation of the heart. As you go down, you can start to get more innervation of the vessels of the providing regulation of blood pressure within the splanchnic region in the gut. And you can also start to get innervation of fat, so you can have improved fatty acid release, which helps support exercise and movement. And as you go down the spinal cord, you see that you get increasing innervation of all of these autonomic or sympathetic tissues in this case. So you can see that as you go down, you get increasing levels of functionability and then therefore also increasing ability to perform exercise. And then finally, when you're at a level of around L2, you've got full innervation of all of this vasculature, pretty much, except obviously you don't have appropriate control of the muscles of the lower limb. But for most intents and purposes, your ability to exercise is no longer being impaired by an inappropriate or inadequate activation of sympathetic systems of the body. So when I was at the Paralympics in 1992, I had the good pleasure of meeting Rainer Kuschel. And people working in OT will recognize the Kuschel name because he's the person who's responsible for inventing the monotube design for wheelchairs. So he's the one who was the first person to figure out a way to go from the active wheelchair in the old box design, which is shown here on the lower right, to the monotube active wheelchair design, which actually one of his wheelchairs is actually on display at the MoMA in New York because it was such an advance at that time. So he's about 77 years old now, but in 1992, he was still competing in the Paralympics, and he's actually widely attributed as the person who first used the term boosting, although researchers have picked it up after this because he's been training and competing in sports since the 1960s, and he discovered that if he did something to activate these autonomic systems below the level of injury, he could have this planned activation of improved blood pressure regulation, which is the process of activating some sort of nociceptive stimulus, either of the bladder or squeezing off some portion of your leg or pinching your toe or something, which then causes a reflex activation of the sympathetic nervous system, which, because it's uncontrolled and below the level of the spinal cord injury, it then causes this reflex output that happens to be a lot of performance capabilities of the body that increases their ability to perform exercise. So such as sweating, such as increasing blood pressure, and also increasing not heart rate, because that usually goes down, but when people do this during exercise, they report that it actually doesn't decrease the heart rate, although it does when you're resting, but that's an aside. Anyways, one of the things that was of interest at this point in time was that boosting is banned because it has the potential to be life-threatening, as I mentioned earlier, in terms of the uncontrolled autonomic dysreflexia. But during exercise, it's the athlete's purposeful activation of spinal sympathetic systems, which causes sweating, increased blood pressure, and also possibly adrenal gland catecholamine release. And the underlying neural mechanisms for this remain unclear. We don't really know what the neural pathways are or the receptor mechanisms that are involved, although they likely do involve reflex activation of these remaining propriospinal or neural connections that are completely in the spinal cord and left intact below the level of an injury. And this would be called an ergogenic strategy to improve exercise performance. And so it is banned because of the potential for death if it goes uncontrolled. But as I showed you earlier in the day in the life, people can inadvertently have episodes of autonomic dysreflexia that can't be controlled. So the ability to determine or to activate it purposefully is the ability to directly target these systems and to appropriately and without damage activate them is a research goal that's important and ongoing, because if we can tap into the circuits for their benefits, but also do that without causing undue harm or unnecessary health risks, that would be an important research goal. And that is actually the focus of a lot of research that I do in preclinical research models, and also involving people with spinal cord injury in collaboration with others at the University of Manitoba, like Dr. Jeremy Chopek and Katinka Stasina and Rodrigo Viller and others as well. So I wanted to give that to you sort of as an overview of the functional losses that occur after spinal cord injury that are outside of the normal functional losses that we think about in terms of paralysis and loss of sensation, because these are key to performance and the ability to perform an exercise. And they also relate to, the widespread sedentary related secondary consequences that occur after spinal cord injury, such as obesity, cardiovascular disease, type 2 diabetes, and all of these things that go currently unchecked and that occur at very, very high levels after injury, at early onsets, and that they're usually the reasons why people are dying early because of these cardiovascular diseases or type 2 diabetes that they get because they have an inability to activate their systems, either for energy control to reduce your obesity, but also as it relates to activating these subsystems so that they're not being activated appropriately. We don't really know why. We need to figure out how we can try and target those systems specifically so that we can provide for a more coordinated and appropriate activation of these reflex pathways that will be beneficial for people when they're exercising. And that is far away, and that's we need to do a lot more basic science research in order to be able to be anywhere for that. So in the meantime, one of the things that we can focus on are ergonomic strategies to improve exercise. And so that's part of the researcher perspective that I'm going to mention today. And I want to talk a little bit about strategies to increase the health benefits of exercise, focusing on these ergonomic strategies. And we won't really get into underlying mechanisms, but some of the research that we're doing is trying to identify why particular ergonomic strategies might actually work to improve exercise performance in people with spinal cord injury. And as you can see, my focus has mainly been on people with tetraplegia level injury. And the reason for that is because they represent 40 to 60% of the population with spinal cord injury, and they're the most severely impaired. And it's mainly because of these impaired sympathetic autonomic functions, which also have the most likelihood for us to improve performance, whereas people with lower level of injury have got better functionality in that regard. And so there isn't as high a functional need for that type of research, but it is important as well. So I want to talk about this as it relates to rehabilitation and also exercise. So we talked about exercise performance for Paralympic athletes, but the average person who has a spinal cord injury they've got really limited exercise options. And one of the key exercise capabilities that are present in rehab, and also that's relatively inexpensive and available for people after injury, is the arm crank ergometer, which is shown here. It's a relatively safe option. Those of you who are in rehab, you all know that the arm ergometer is present in the rehab hospital, and for someone with tetraplegia or thoracic spinal cord injury, it's really one of their only exercise options until you start getting into hand cycles and racing chairs, which are also extremely expensive, on the order of $8,000 to $10,000, whereas ergometers are a little bit cheaper. But the current recommendation for arm ergometry is to use the arm ergometer such that the crank is at shoulder height. And what that means, and this has actually been prescribed for the American Medical Association, is throughout the literature, it's always recommended that you position the crank so that it's at the shoulder height. And that means that for half of the arm crank cycle, your arm is going to go above the crank axis. Whereas if you were to position that crank axis lower, your arm might remain below the level of your shoulder. And the reason I'm mentioning that is because we know from the rest of ergonomic research that you try to avoid exercises that are above the shoulders, because that's leads to the greater likelihood of shoulder impingement syndrome, rotator cuff injury, and all of the other negative consequences of that, which people with spinal cord injury are at risk of, and those injuries are almost ubiquitous in that population. So We would want to see whether or not the level, oh, and it's also important because I think as the level of injury increases, the variability or the functionality of people with spinal cord injury decreases. And so you need to try and optimize exercise performance that targets people with higher level of injury so that you can maximize their ability to exercise. And it might be small changes, but if they can improve people's functionality and lead to even slightly improved exercise output, that's a valuable goal, and one that's relatively easily translatable to the clinic and translatable to people's lives in the decades after injury. So our goal was to determine if changing the arm crank height makes a difference to peak or steady state exercise performance using an arm ergometer. We did that by looking at two different positions, one at the recommended height, which is a high crank height, so that your shoulder is at a 90-degree angle and that you crank 50% of the time above the shoulder and 50% of the time below the shoulder. Then our second choice was a low crank option where the hand remained below the shoulder throughout the arm crank cycle. And we had people do a peak incremental test to exhaustion, which involved a rest period, and then every 2 minutes we increased their resistance on the ergometer and then saw whether or not they fatigued earlier when they were cranking at either the high or the low height. We also did a steady state test, which I guess my text is gone from that, where they exercised at a steady state level, which was 80% of their peak power output, which was determined from this first peak test. And the reason we did that was because we wanted to standardize exercise so that they were doing it relative to their own personal peak performance. So when we did that, we found that their peak performances were similar at the high or the low crank height. It really didn't make any difference. All the stats are here, but none of them were significant. The only one that was significant was when they did the steady state test, their time to fatigue was significantly different when performing it at the either above or below shoulder level. So we looked at the parameters, the underlying metabolic parameters, to try and find out, well, what were there differences in either their relationship between their oxygen uptake and their carbon dioxide release? Were there differences in their minute ventilation? Were there differences in their relative VO2? And we plotted this over the time that they were exercising. We did this for each person. There were 11 people in the study. We looked at their ratings of perceived exertion on the Borg scale. We looked at their heart rate. And you can see that the patterns are very similar here. And just so that you know that arrows pointing down are the below crank axis, the arrows pointing up are the high crank axis, and then the symbols are related to red is for O2, blue is for CO2, in this one green is for the ventilation rate, and then in here this is more specific, but it's relative VO2, and then the RQ, which is a measure of whether or not you're using carbon dioxide or fatty acids as your energy substrate. But basically, they showed no difference whether there was heart rate, ratings of perceived exertion, or VO2 or CO2, except that at the low crank height, people were able to exercise longer. And you can see here at the ratings of perceived exertion that they were maintained at a lower level for a longer time period before they started to peak and then get to that same peak height when they did fatigue. And the difference for this individual was 500 seconds versus around 1,200 seconds. Which, is 10 minutes versus around 18, 16. There's quite a big difference. Now, and so similarly in terms of O2 and CO2 and minute ventilation, once you got to the fatigue stage, yes, they were all elevated or they all changed. But we looked at all of these for all 11 people in the study, and when we compared the endpoint values, either at the low crank or the high crank height, they were not significantly different, except that they could exercise longer at the low crank height. And this is both the mean data in the high crank position and the mean data in the low crank position. And here are the individual values. So you can see in this p-value, and this is a different p-value than the previous graph because we had 11 people at this point. That one was a preliminary assessment when we only had 8. But basically, you can see that they were able to increase their performance and that they could use the arm ergometer for a significantly longer time when it was at the low crank position. And that p-value is fairly significant at 0.0088. So we're still looking at using, well, I'll say it here, NIRS or near infrared spectroscopy to try and see whether or not the reason why they could exercise longer had to do with oxygen delivery to the active muscle, because we saw no differences in their whole body metabolic output parameters. So we're still trying to figure that out. But what we can recommend at this point is that if you are prescribing arm ergometry for exercise when you're doing rehab therapy, or if you're in the inpatient or outpatient clinic or working anywhere in the rehab field, that you recommend that people exercise below the shoulder level and not at the high crank axis level. And also, it speaks to the fact that even small ergonomic changes can make large differences in performance. And this is particularly critical for those operating at the limits of their functional capacity. And that would be people with higher level of injury. And the reason I say that is because if you look at these actual times, people with particularly with higher level injury can only exercise continuously for 100 or 200 seconds. So we're talking about 2 to 3 minutes before they fatigue. And that relates back to some of the earlier stuff that I showed in terms of their blood pressure instability and their inability to regulate their homeostatic body functions, as well as their ability to increase blood pressure to provide enough blood pressure so that you can increase the delivery of oxygen and the uptake of carbohydrates that are within the active contracting muscle and bring it back for clearing at the lungs. So all of these things work together, and they do make a large difference in performance. And we need to understand more so what the underlying neural mechanisms are for this. But I just wanted to show you what we do have and what we can say in terms of what we know at this point that is clinically relevant. And then my fourth point and my second health or research pat relates to some health policy research that we've been doing to improve access to needed medical services, supplies, and equipment that are essential for life after spinal cord injury. And basically, this looks at, well, what can we do with the information that we already have to improve health and life quality for people living with spinal cord injury? So this was done in collaboration with Jackie Repat, as well as Peter Athanasopoulos, whose name I could never say correctly. And he is with SCI Ontario, and his role is policy for Spinal Cord Injury Ontario. And Peter Warkentin and John Gregory helped us out in terms of the research that was done for this study. But basically, we looked at the provision of essential medical and technology supplies and services for those living with SCI in Canada. We did it for all of the provinces. And we had a report, which is shown here on the left, which was identifying jurisdictional gaps in providing these essential attendant services, supplies, and assistive devices in Canada. And the reason, or our background for this, was that we do live in Canada, which does have a universal healthcare system and is developed to provide public coverage for essential medical needs. But we also know that the federal transfer payments to provinces results in discrepancies in the delivery and coverage, because each province has quite a large degree of latitude in terms of what it determines to be essential. And so they are defined as a service or a piece of medical equipment that, if withheld, would result in the death of a person. Our definition was it would result in the death of a person with SCI within days or weeks. So we had 3 domains that we looked at: attendant services for activities of daily living, medical supplies for bladder and bowel function, to manage the fact that their autonomic systems are not working properly and that they have autonomic dysregulation. And so they cannot have, no longer have voluntary and appropriate activation for bladder and bowel activation or evacuation. And then assistive devices for mobility, in particular wheelchairs and transfer devices. So the reason why we picked those is because not everyone requires attendant services for daily living. It depends on their level of injury. But for those who do require it, if they don't have attendant care for activities of daily living, they will die on the order of days and weeks, because they won't be able to perform these other functions, which are managing bowel and bladder or moving. And then the neurogenic bladder and bowel evacuation supplies are required for pretty much anybody with a spinal cord injury, depending on their extent of their injury. And if they don't have that, they will also die of either related complications from constipation, bladder reflux, as well as all of the others that actually did kill people during the 50s and the 60s, until they figured out other ways to manage bladder and bowel function. And then assistive devices for mobility, because if you don't have a wheelchair and you can't walk or ambulate, that is essential, because you won't be able to do number 1 and number 2. So they're all interrelated, and they're not essential for everyone, but for people with spinal cord injury with particular levels of injury, they are essential. So we did an online environmental scan, and we reviewed all the available provincial health policy documentation that were either within the public system and the insurance-based system. We did it for each of those 3 domains for people living with SCI, and we did it in each province. We also followed this up with key informant interviews, and which were 1 to 3 hour in-depth interviews using structured guides. We had 16 participants across the country who held expert knowledge of this as it relates to each province. And then we also had a peer review of the people that helped us direct and organize the study and inform the study for accuracy and completeness. And what we found was that there's significant disparities and inequalities between provinces for each domain of essential need. And we also found that the access to information and also identifying or accessing essential services and supplies was often difficult to access or request. And it often involved complicated financial and functional assessments, and they were performed only by designated personnel, and they also involved excessive wait times. And despite their extensive lived experience, people living with SCI were typically relegated to being a passive recipient, and they were often subject to repeat assessments of financial and functional status. And this was to receive minimal and often inadequate essential healthcare services supplies. So, I'll get into the details of it, but there was quite extensive. And you might have to go through a repeat financial assessment on the order of every few months just to receive 3 to 4 catheters a day, and so you had to keep doing that, and you also had to keep proving that you needed it, even though you have spinal cord injury is a lifelong change, which you don't need to have a prescription for that every time you want to get this reassessed in order for it to be funded under the provincial healthcare authority that you live in. So we looked at means testing, which means whether or not people's income is assessed to determine whether or not they'll be provided one of these essential supplies or services. And we separated that out by province, and we separated out for activities, attendant care for activities of daily living, as well as the neurogenic bladder and bowel supplies, and then also for manual and power wheelchairs. And so you can see in British Columbia, they means test for each of those domains of need. Whereas in Alberta, they do not means test for attendant care or for wheelchairs, but they do means test for bladder and bowel supplies. In Saskatchewan, they means test for attendant care, and they don't for bladder and bowel supplies, and they don't for wheelchairs. So you can see that there's a wide disparities across the province. It varies by province. There's inconsistencies across domains, and there's also inconsistencies in terms of level of allowances, except for when you get to the federal regulated programs like Veterans Affairs or the NIHB, there's no means testing across the board for any of those domains of need, which is interesting because it's a federal system. And in those cases, they don't means test for any of those needs, which are obviously considered essential at the federal level, but apparently not at the provincial. So when you look at that, these means testing processes are put in place for attendant services in 5 of 10 provinces, and that's for British Columbia, New Brunswick, Nova Scotia, Newfoundland, and Saskatchewan. And they can involve substantial fees with even with income that's below the poverty line, or sorry, that's income that is just at or above the poverty line. And I'm going to give 2 examples, which we don't want to go through in detail, but I just want to just highlight. If a person's earning between $13,000 and $18,000 a year, they can pay 24% of those earnings for attendant care services. So that's different than Manitoba, we know, because attendant services are not means tested. In Saskatchewan, means testing is both based on means, but also hours of need. So the more hours of attendant care that you need, the higher you have to pay, which is really contradictory and contravenes a person's ability to work, especially at higher levels of injury. So you're giving them a double barrier to trying to contribute to society. And then in terms of just the provinces that don't means test, which include Alberta, Manitoba, Ontario, PEI, and Quebec, it is better because it's not means tested, but it's still considered inadequate in many provinces. And they find it most lacking in rural and remote settings and Indigenous communities. And I think, we all know that for any services, for health services, that's a widespread problem. It's not restricted specifically to spinal cord injury and attendant care. One of the things that was noted in Ontario, which was kind of which we don't face here quite so much in Manitoba, but because they use a dual system of both public and private home care, what they found is that there was a lack of transparency and responsibility to report. So the private companies delivering home care, and this became particularly evident during the pandemic, was that in those in cases where private companies were providing care, there would often be attendant visits missed, putting a person at risk or health crisis, especially if they were living alone. And there were no repercussions for the providers, so that when Ontario Health went to renegotiate those contracts, whether or not they had done and provided the appropriate number of services that they had been contracted to provide was never a part of the equation as to whether or not they were negotiated for future contracts. So there's a lack of transparency and a lack of accountability. And then, you know, overall, there was often scheduling difficulties and lack of resources, so that you might have, you know, for someone with, say, a C4, C5 level injury who can't transfer or perform any activities of daily living, they might be tucking into bed at 7 p.m. and then not being brought out again until 8 a.m. So you're spending, you know, 11 to 12 to 13 hours a day in bed because of a lack of services. So there are also alternate delivery models that do come into play. We know that in Manitoba in terms of self-managed attendant care, and SCI Manitoba and Independent Living Resource Centre was very important for developing those things. And we also know, you know, that Manitoba is a leader in terms of at least developing these attendant care services, but they are developed for people who are aging or have a short-term need for health services, not really for the perspective of people who might have long-term, decades-long needs for attendant services. And then in terms of neurogenic bladder and bowel supplies, they're means tested in 9 of 10 provinces, all except Saskatchewan. The coverage in each province varies widely. You can limit the public provision. Often provinces limit it to only those who are receiving social assistance or under the poverty line, which is actually what happens in Manitoba. It can be associated with employment insurance, or if you're receiving home care or EI. But if you're not receiving home care and if you're employed, then there's no public coverage for these supplies here. And so it differs. Like Alberta, actually, if you look at that province, has probably got the best system in place in that they have very minimal co-pays for the individual spinal cord injury, and they top out at a really low level. And so people can be earning a fairly, not high, but around $40,000 a year level of income. And then they would then trigger their payments, but they also get topped at, say, $500 a year. So it's not exorbitant. And so that as those costs rise, their cost also doesn't rise. And it's a way to sort of limit the very high cost of some of these things, which relates to bladder and bowel, but also relates to wheelchair supplies. The other thing that came about was that none of the provinces, with the possible exception of Saskatchewan, provide sufficient coverage to meet the quality and quantity of catheters that are recommended by the Canadian Urological Association. So they suggest for people with neurogenic bladder that you use single-use coated catheters, so that they limit the damage to the urethra, and they also they want them to be single-use as opposed to being reused. And then which I mentioned, and they also limit the numbers to in different provinces, but the Urological Association recommends 6 to 8 per day, whereas other provinces, especially in Atlantic Canada, they have daily limits ranging from 1 a day to 4 a day, which obviously means people are going to have to reuse their catheters. They also state right in their public documentation is that it'd be the most inexpensive option available, which is fine. We want to be fiscally responsible, but we also want to make sure that we're not causing damage to people that's then going to later result in very costly surgeries or very high infection rates, which are also expensive to treat. I'm not going to go into the details of this, but we did extensively look at the specific levels of coverage as it relates to their income. And we also provided data to look at the modeling and how each individual would be impacted depending on their level of income and for varying levels of need within each of these domains. And just for example, in British Columbia, as soon as you're off social assistance or you enter the workforce, you pay 100% of the cost of these things. Alberta, as I mentioned, they've got maximum annual contributions of $500, which is much more amenable to promoting workforce participation. And then I'm going to move on to our final one, which is powered manual wheelchairs. And again, the story is similar. There's shortages, exorbitant wait times for assessments, ordering and delivery, consistently reported. And I think in Manitoba, we know that this can be a stumbling block for people to be released from inpatient care, and people can wait on the order of a year before they might receive a power wheelchair, often having to rent wheelchairs in the interim, which are often inadequate, don't fit properly, don't work properly, and there's a whole plethora of issues related to that. Wheelchair provision is means tested in 4 of 10 provinces, British Columbia and Newfoundland, Ontario, and Prince Edward Island. Most provinces' equipment is limited to the most inexpensive suitable option, whereas others like Ontario do have a list of vetted technological options that is updated periodically and that does receive information from groups of people like physiatrists, people with lived experience, occupational therapists, physiotherapists, who are expert in spinal cord injury, who can then identify appropriate functional devices. And that's actually rare. It doesn't exist in other provinces. In other provinces, in 3 of 10, including Manitoba, New Brunswick, and Nova Scotia, they, rather than the provincial government maintaining the program, they use a loans-based provision in 6 of 10 provinces. And so in Alberta, Quebec, and Saskatchewan, those are provided by the health authorities, whereas in Manitoba, New Brunswick, and Nova Scotia, charity organizations take over that role. And the money then is given to the charitable organization, and then the charitable organization is responsible for distributing that loans-based program, which can have problems in terms of both the accountability, and also it actually puts the charities in a poor position, because they may not be receiving adequate funding, and they're left to then meet the needs of the population with very limited budgets, but there's no direct accountability between that provider and then the provincial government and the health authority, and the responsibility for that. Whereas in Alberta, Quebec, and Saskatchewan, that's taken on by the health authority, and so they're more aware of, or at least have control over, the ability and the responsibility for provision of those pieces of equipment. And then often in provinces that use a loans-based system, they don't include all of the components that are needed. So for example, cushions and backrests are not provided in some provinces, including Manitoba, unless you can demonstrate financial need, but then it may not be appropriate, and you may be limited to the cheapest option, which may not be the best from an occupational therapy perspective, to prevent injuries, or for an ergonomic perspective to improve function. And as I showed in the earlier part of this talk, those very small ergonomic changes can have a critical role in whether or not an individual, particularly with higher level spinal cord injury, can function adequately with the equipment that they have. And so they can have only 1 or 2 models available from 1 or 2 suppliers, which is inadequate. And it's not an issue of choice. It's an issue of trying to find equipment that has an adequate range of capabilities to meet the very small functional capabilities of the individuals that we're trying to provide equipment for. And then, we did the same thing again, where we did a fairly extensive and comprehensive financial assessment, and this is all detailed in this report. And we are waiting to hear whether or not that report is going to be published very soon. And I just want to round up with some of the themes and quotes. We did also get information from key informants, but basically overall there was a significant difficulty in recruiting or retention of attendant care workers. There's disincentives to leave social assistance due to loss of coverage for essential health care. There's limited lack of catheter provision, which leads to inappropriate non-sterile reuse and or restriction of fluids, so that you don't have to catheterize as much. And basically, people, the key informants believe that the system is failing to meet the needs of people living with SCI across the country, and to varying levels in different provinces. But I want to just end with this last quote that I've highlighted in blue. And I actually thought, is this true? There's a lot of people in New Brunswick choosing medical assistance and dying because they cannot get the supports they need from the disability support program. Access to specialists such as pain management specialists is also failing. And if people are paying attention to some of the news lately, this has been in Quebec. There were 2 people who made the news because they chose MAID, rather because they couldn't get access to the attendant care services that they needed. And so they just chose to take advantage of MAID because there was inadequate supplies and services. And we know we've seen that in Manitoba as well for people with ongoing progressive neurological dysfunction. That's been in the paper in Winnipeg as well. So the conclusions are that attendant services for ADL are essential. Current levels are inadequate and should increase. Means testing and limitations to the availability and coverage is short-sighted and can lead to substantial increases in long-term costs to society and the healthcare system. And that, again, the same thing is true for power and manual wheelchairs, and that we do need functionally appropriate wheeled mobility and it should probably be more consistent across the country. Perhaps what we need is a nonpartisan, objective scientific review body which can determine definitions of essential healthcare in Canada, and also some sort of basic minimal allowance for these essential medical supplies and services that are informed by research and by functional research rather than the political jurisdiction in which one lives. And this becomes particularly relevant when you think about means testing, in that, you know, the decision to means test is very much under the purview of the province. And so, for example, and yet there's consistencies across the country for particular types of healthcare needs, such as kidney dialysis or cardiovascular stents. They're considered to be an essential need, and they're funded across the country, regardless of the province you live in. And they're not subject to means testing, such that, you know, if you earn $15,000 or $20,000 a year, all of a sudden you're responsible for funding your stent or for funding your kidney dialysis. So it highlights sort of the distinctions that are present within the system that are particularly onerous for people living with spinal cord injury. So these are my acknowledgements. I've worked with Barb Shea, I've worked with Ed, although that we didn't talk about Ed's research here, so you're not in here, but I've had the great pleasure of working with you many times over the years. Rodrigo Villar, Karen Ethans, who's responsible for inpatient and outpatient SCI care, students and staff who have helped in terms of multiple projects. And then in terms of policy research, people that we've mentioned, as well as the steering advice and information from the Spinal Cord Injury Federation of Canada, which includes also the federations within each of the provinces. And then, of course, funding, because none of this would be possible without support from all of these different agencies. And I was hoping to finish at 12:50 in case there was questions, but I didn't. But I'm done now.
All right. Thank you so much, Chris. That was absolutely wonderful. I know it's a lunch hour presentation. I feel full after that. It seemed like 5 presentations. There's so much information there. We've got 4 minutes here. So if someone has a question, if you want to either put up your hand and I can call on you, or put it in the chat. But are there any questions for Dr. Cowley? Brian, why don't you go ahead?
Hi, Chris. I was just curious. Maybe you'd mentioned it in competition, but in other situations as well. Do people use compression garments on the lower limbs to try to manage blood flow distribution?
I didn't mention it, but they have done experiments on that. They have tried to do it, and they found that it in research, it didn't seem to make a difference. People may use them themselves because they feel it helps in terms of edema and everything, but it didn't seem to be sufficient to adequately drive the system from the lower limbs. But they haven't looked at intermittent stimulation or contractions that might be more time, and I think that would be something that could be done to take a look at that.
Yeah, and I guess, maybe also whether, posture of exercise could be, trying to raise the lower limbs a little bit or something like that to try to promote, I guess, more advantageous blood flow. And if I can sneak one more quickly in there, for the individuals in their changes in exercise time, in shoulder versus below. I mean, some had a really robust response to that, and some were. I'm sure you've looked at a little bit of subgroup analysis. Is there a hint of anything going on between those who showed a really promising change and those who didn't?
Yeah, it seems to be that the people who can achieve a steady state, especially during that testing that we did, it was more. So it was sort of like an inverted curve. So the people at the bottom who had very limited ability, probably their blood pressure regulation and everything else was so poor that they couldn't even achieve a steady state at that 80% of peak. So then the advantage of the arm crank height difference was less, but that was at 80% of peak. If they would exercise maybe at 60% of peak, it might actually make a more significant difference because they're not so close to their ceiling of their functionality. And then for people though who are above it, and we didn't get the numbers that we wanted to, and I'd like to extend it, but our goal was to compare paraplegics below T6 to people with injury above C8 so that we could really see the difference. Because I would expect that people who are lower level injury would not be as fragile in terms of the ergonomic positioning because they're operating further from their ceiling. But we actually found that people with paraplegia level injury also could go longer, but it did relate to whether or not they achieved a steady state and also how fit they were. So I think there's a window there, and there's something that and fitness was a factor too. Like if you were unfit and you didn't exercise and you couldn't reach that steady state, it wouldn't have as much advantage for you. But those are the things I think that are key.
Thank you.
All right. Well, unfortunately, we have just hit the 1 o'clock time, so we'll have to close it there. But once again, I will express my appreciation to Dr. Cowley for a very engaging and informative presentation. And thank you all for joining us today and attending.